Many organizations try to accelerate field operations by layering artificial intelligence over legacy workflows. But AI is an amplifier. If the underlying process is broken, the technology just executes that flawed logic faster, pushing the technician further away from a resolution. AI is usually designed for work as imagined, the clean process documented in the handbook. But work as done is a tangled map of unofficial shortcuts. Gaining clarity requires surgically identifying this mess, removing redundant approvals until only the core notes remain. By simplifying these paths, you reduce the cognitive load on your technicians. When the process is clear, it becomes easier for a digital system to guide a human worker through a high-pressure task. Once a technician sees that the system consistently helps them succeed in the field, trust begins to form. Demonstrating these reliable wins is how you move from a tool that is bypassed to one that is adopted. To reach this state, leaders have to leave the conference room. They must run a ground truth diagnostic to map what is actually happening in the field before they attempt to automate it. Step 1 is the day-in-the-life observation, or DILO. This involves passively shadowing the top 10% of your technicians while they are managing live, high-stakes jobs. You are actively looking for shadow workflows. These are the undocumented communication channels and shortcuts your team has developed to survive the pressure of their daily schedule. You might see a technician ignore a cumbersome 12-tap diagnostic app to immediately video call a senior peer. That call is a shadow workflow, a more efficient path to the fix than the official software provides. Mapping this reality is critical. If you train an AI on the official manual that no one uses, it will fail. If you train it on these expert shortcuts, the system supports the way work actually succeeds. Once the observation is complete, step 2 is workflow decomposition. You break the real work down into its modular parts, the specific triggers, actions, and decisions required to close a ticket. Record the physical cues the technician uses. They might look for a specific heat pattern on a component, or listen for a vibration that isn't captured by any digital sensor. You also document the exact moments where the technician intentionally bypasses an official system. These gaps represent the points where the current tools are failing to meet the needs of the moment. Breaking the work into these tangible blocks reveals where the cognitive load is highest. It shows you exactly where technicians are being forced to think too hard or wait too long. Step 3 is the gap analysis. You place your documented standard operating procedure on one side and the actual observed workflow on the other. It is easy for management to look at these deviations and see compliance violations. But punishing workarounds is a mistake. These deviations are often expert adaptations. They are intelligent responses to time pressure and system inefficiency designed to keep the operation running. Analyze the gap by asking what the technician gained by deviating. Usually, it's a specific operational advantage, like faster diagnosis or better clarity on a complex issue. Understanding this gap prevents you from automating the wrong things. It ensures you don't eliminate the adaptive behaviors that actually make the work functional. Step 4 is purging process debt. This is where you apply the kill the form rule. Eliminate any data entry field or approval step that doesn't trigger a meaningful action or reduce a real risk. Now you form your redesign hypotheses. For example, replacing a manual 10-field form with an automated image extraction tool reduces decision cycle time. Every new interaction must pass the 2-minute rule. Tasks taking over 120 seconds fail under high pressure. The redesigned process must require minimal input. It has to work for someone standing on a ladder in the wind, not just someone sitting at a desk. Stripping out this process debt ensures the AI accelerates a solution. If you skip this, the technology just speeds up a bottleneck. Step number 5 is the pilot design. This is where you shift the AI from a passive search tool to a push-based guide that provides real-time support. Instead of making the technician look for information, the system pushes contextual prompts directly to them at the specific moment of work. This requires human validation. The technician checks the AI's suggestion against the physical reality of the machine and confirms the next step. This cycle creates a positive feedback loop. Every time the technician validates a successful fix, the AI becomes more accurate, and the human worker becomes more confident in the results. Executive mandates can't force technicians to use a tool that slows them down. Adoption is built on this trust loop. proving to the frontline that the system makes their job easier and more successful. By completing the ground truth diagnostic, you align your company's processes with the way work is actually performed under pressure. Chaotic shadow workflows are replaced by a system where human judgment is supported by machine intelligence. The technician stays in control, but they are backed by real-time, data-driven insights. AI doesn't fix a broken process. It just amplifies what's already there. That's why you must strip away the debt and simplify the steps before you turn on the automation. Stop deploying tools into environments they aren't designed for. Start redesigning your workflows to embed intelligence at the moment of work. Download the Playbook to start your diagnostic.
For more insights, subscribe to Purposeful Nudge and start rewiring your field services organization today.